Hello all, welcome to my YouTube channel Satya Eval. So today's lecture we are going to see about the Unit 3 3G networks. Before going to 3G networks, let us have a comparison between the 1G, 2G, 3G, 4G and 5G networks. So these are all the started year of deployment for 1G, 1970, 1980, 1990, 2000 and 2010, and the corresponding bandwidth which is required for 1G is just 2 kbps is sufficient, since it supports for advanced mobile phone systems AMPS, and which works with a technology which is analog cellular technology. And for the 2G system, it requires 14.4 to 64 kbps, and it follows a technology called TDMA, time division multiple access, CDMA, code division multiple access, and GSM, which is global system for mobile communication, as well as GPRS, general packet um, radio system network, then followed by the digital cellular communication technology. So in sense 3G uses a 2 Mbps bandwidth, and it uses a wireless CDMA technique as well as CDMA 2000 technology, so which has an advantage of broadband, providing broadband bandwidth, CDMA and internet packet technology. Then coming back to 4G network, which supports from 200 Mbps to 1 Gbps for low mobility. Then it uses a single unified standard, then unified IP address and seamless combination of broadband and LAN networks. Then coming back to 5G, which uses a 1 Gbps and higher data rate, and then which is also having a unified IP and seamless connectivity of broadband. So this is a 2G network and 3G network, which consists of voice network, which uses a symmetric physical connections, that is circuit switch network, and which is a combination of voice as well as data. Data is nothing but a packet switch network, which is capable of transferring and utilizing asymmetric connection less links, that is packet switch network. Then 4G, they have removed the voice and they have used only the data. So this is the standard for 1G, 2G, 3G, 4G and 5G networks. So this is the 3G network architecture model. So in the 3G network architecture model, we have the mobile station. Mobile station is nothing but it is a user equipment. User equipment consists of SIM card along with a mobile phone. Okay, SIM card is subscriber identity module. So coming back to the network, which is a radio access network. Radio access network consists of two components. One is base station, which is nothing but node B. Another one RNC, which is nothing but radio network controller. Next network is a core network. Core network works with two technologies. One is connection oriented, which is meant for telephone calls or voice calls. Then for connection less, which is nothing but packet switch networks for with internet. Wherever we go, we can use a wireless internet. So for circuit switch network, we have to have the physical connection, first followed by mobile switching center, then gateway mobile switching center, which is connected to a circuit switch network, which is connected with the physical links. And whereas next is a packet switch network, which is a SDSN. SDSN stands for Service GPRS Support Node. And followed by SDSN, we have GGSN, which is GPRS, that is Gateway GPRS Support Node. GPRS stands for Generic Packet Radio System. And IMS network, which is not used in 3G, but it is supporting for 4G systems, which we'll be learning later in the unit 5 for 4G networks. And next is the Internet Protocol network, which is connected with the core network. So this is the overall model of the 3G network architecture model: GGSN, MSC, GMSC. So next we have the radio network controller, which is connected with the physical node B with a interface which is IUB interface, and the interface between two RNC is IUR interface, and the interface between core network to the radio network subsystem as an interface which is called IU interface. So we'll see the responsibilities of this. RNC consists of two elements. RNS consists of two elements, node B and RNC. Node B is nothing but base station. RNC is nothing but radio network controller. So the radio network subsystem consists of responsible for maintaining the radio resources, that is, whichever information is transmitted and received through free space with a set of cells. We know that cellular system concept, we have the cellular networks which is followed with a hexagon shape. So in the hexagon shaped cell sector, we can able to have a base station along with a mobile switching center, such that we can able to transmit and receive information through the antenna. So RNC is responsible for use and allocation of all the radio resources for which the RNS belongs to. And RNC also handles the user voice in terms of telephone normal calls, packet data traffic in terms of handling asymmetric, that is, for example, when we travel, we send a video or an audio or any kind of animations or any movie format, anything, MP4 format, anything else that forms a packet, so which able to handle the data traffic for the user data streams. And the responsibilities of RNC is to maintain and hand over the intra-neutron handover. We know the handover process searching for the signal connectivity where they are very weak. And macro diversity example is combining and splitting of the user data, that is IUB. And frame synchronization, transmission and reception of the frames. And then radio resource management. Then this is a responsibility comparison between RNC and Node B. We'll see how the RNC is responsible. RNC is responsible for intra-RNC handover. Node B is responsible for termination of IUB interface from RNC. And RNC is divides the frames and for the transmission as well as reception using the frame synchronization concept. And Node B with respect to encoding and decoding for the radio channels. And radio resource management is the main responsibility of the RNC, and whereas Node B checks for error detection and correction for the transport layer and higher layers. And UMTS radio link control can be established using RNC, and frame and frequency and time synchronization can be done using Node B. So these are all the additional requirements. So this is a Utron GPRS network architecture module. We have already seen this: user equipment, base station, subsystem model, network subsystem model, and other networks. User equipment consists of SIM card and mobile phone. Then base station subsystem consists of BTS, base transceiver system, and BSC, which is with respect to the base station controller, and MSC, which is for mobile switching center, and VLR, visitor location register. GMSC is for gateway mobile switching center. EIR, which is for equipment identity register. HLR for home location register and authentic center. AUC, authentication center. Then followed by the other networks, which is public switch telephone networks, and PLMN, which is public LAN mobile network. So these are all the logical interfaces. We need to establish the logical interfaces between two layers, which is radio network layer and transport network layer. So we'll see radio network layer. So the radio network layer is application protocols will be working along with the radio network layer, and user plane along with the data bearer services for the transport layer. So the transport layer consists of TNL and TUL. TNL is responsible for transport user services, and network plane responsible for call signal controlling services, as well as ALCAP, which is access link control application part, which is useful for transmission and reception of the information through the frame synchronization mechanism. And these interfaces, which basically includes the data streams, data bearers, which is needed for the data streams, and ALCAP, which is for access link control application part, which is to set up the transport bearers for the user plane. So finally, this includes all the transport layer information between the control plane and the user plane, which is useful for providing signaling bearer needed for the ALCAP. And this is totally independent of the technology which is useful for transmission and reception of the information, which is for the user plane. And this is the logical interfaces. So control plane, user plane, transport network control plane, transport network user plane. So transport network control plane, which is useful for the signaling information along with the data signaling bearers and the access link up part. So this consists of two network with the application protocol as well as signaling bearer. Application protocol consists of two. One is serving for application part, another one for base station part. So application part is for RAN, which is for radio access network, the radio access network application part, and radio access network, which is useful for the node B part, which is for IUB interface. IUR interface is for RNSAP, which is for radio network subsystem application part, and a signaling bearer which can able to send the information and receive the information through the transport message application protocol. And this application protocol is used for setting up the bearers to the user network. So we have the different scenario in sense. First is we have the mobile phone. The mobile phone along with the SIM card is user equipment, which is having an interface which is a UU interface between the Utron network, and the main interface is connected with the node B to the RNC, that is said to be called RNS, radio network subsystem. We all know that very well familiar. And then this in turn sends the data which is with a radio access bearer in IU interface and radio link in IUR and IUB interfaces respectively. So this is user plane, which is responsible for transforming the coded voice in a voice call and packets in an internet connection. This includes two parts. One is for data stream, another one data bearers. Next is circuit switching and packet switching technology. We have already seen circuit switching works for voicemail and free phone calls. Packet switching works for internet access and multimedia services. This is IU interface. These interfaces we have already seen. This interface is working with a RNCP and TNCP and user plane. So RNCP is radio network control plane, TNCP is transport network control plane, UP is user plane. So this is the general GSM UMTS network architecture model. This consists of the UMTS Utron network along with the additional network which is providing for national ISDN, which is integrated services distributed network, along with the intelligent service center point, INSCP. So using this network we can able to establish the communication through the global system mobile communication through the 3G network architecture. So the 3G STSN servicing GPRS support node functions is mainly for mobility. When the user is moving from one location to other location, it searches for the data transfer with the access point, and session management to initiate the session or to terminate the session. To continue the session, we need the session management. So IU and GN interface is needed for that, and a subscriber database functionality. Whoever the corresponding subscriber, the particular database and which functions they need, and for charging the system, and for ATM along with the asynchronous transfer mode along with the ATM adaptation layer type 5, and then SMS operation, basic message, short message services, and for operating as well as administration and maintenance. Next is GGSN. The GGSN is useful to maintain the information location at SDSN level, and to provide a gateway between UMTS and external data networks, and to provide route termination for terminated packets, charging, screening and security, and same OAM, which is operation, administration and maintenance. Next comes the technology along with the TD CDMA. We see this in the next video. Thank you for patient listening. If you have not subscribed my YouTube channel yet, kindly subscribe my YouTube channel. Thanks for watching. Have a great day.